Hi everybody, welcome back. So in this video we're going to continue our talk about the physics 2D. So let's get started. Now for this big block right here, it's this little square. So the one that's in the middle of the screen. So what we have for the components is we got our sprite renderer, of course, we got our Rigidbody2D, and we have it set to kinematic. So I'll explain what this is later on, but pretty much kinematic is it won't move unless told by script or by code. And then there's this box collider 2D. I talked about the box or most of the colliders already. So if you guys want to check that out, just look at the previous videos. I'll leave links up above. But anyways, we just have that big block. Now this sky sprite. So we just have that big block. Then we're gonna go to physics 2D. Physics 2D, we're gonna go to relative joint 2D. So when we click relative joint 2D, we're gonna get this green arrow. So let me hide the background real quick. So when you click it right here, this little eye figure on the hierarchy, it turns it off in the scene view, but in the game view you can still see it. So that's a little trick. And then also gizmos, like if these little cameras are bugging you or whatever, you could turn off gizmos right here. But as you can see, you can't see that line. So what you could also do is you could click on the little drop down and either unselect 3D icons or just, you could turn it down so it don't bug you as much. But anyways, we're gonna continue. The relative joint 2D, all it does is it keeps it fixed at a relative position. So let's say, I'm gonna go to sprites. Now these sprites right here, I got it from the Unity Asset Store. It is the 2D Sprites pack by Unity Technologies. It is great. It's a great pack. It's 2.9 megabyte and it contains, let me show you real quick. It just contains these sprites right here. So, I mean, it's not a lot of sprites, but I mean, it does help to get you started. They even have these explosions so you can make effects with particle systems. They have this explosion too as well. They have spaceships, a whole bunch of other random stuff. And then, so relative position, it has to have the other game object has to have a Rigidbody2D. So we're gonna add a Rigidbody2D to this bomb right here, and then we're gonna click on the big block, and we're gonna drag this sprite, the bomb sprite, right into this connected Rigidbody field. And as you can see, it connects it automatically. Now you could have it enable collisions just like any other joint, so we could enable collisions so these two objects can collide to each other. And there's max force. So let me hit play real quick just to show you what's going on real quick with the relative force. So now if I try to hit this bomb right here, as you can see, do I even have a, oh, first of all, let me add a collider to the bomb. If not, nothing's gonna be able to hit it. And let me add a circle collider. I don't know why I cut the box. Just gonna add a circle collider 2D. Kind of shape this real quick. Here you go. Hit play. So now when we hit it, as you can see, it stays in position. Now if I go back to the big block where the relative joint is at, now we have max force. So this is the maximum force that the joint will stay in a relative position. Same with this. This is the maximum torque that it will stay in the relative position. And this is the correction scale. So this is what scales how correctly or accurate it will be. So if I push 1, it's pretty accurate. Now if I put it to 0, as you can see, it doesn't do anything anymore. And then even though it's still kind of tied in together, so if you go to the scene, well actually it's not tied in together no more. So that's what, as you can see, when I adjust this, you can see it connected to it. Now there's also auto configure offset. So if you have this off, you could actually configure the offset by moving these parameters. Also the angle offset, so what angle it's at, and then if you hit auto config, it'll just connect automatically. Now break force, if you have this at a small number, you could actually break that invisible line. So for example, now when I go through it, it'll just break off, start rolling and doing its own thing like it would normally, especially because since it has this Rigidbody and a circle collider, it just rolls. So yeah, that's pretty much that for the relative joint. Let me remove this real quick. And as I said before, if you guys have any questions, because I try to move quick on these subjects, just let me know in the comments below. I'll be happy to answer them. There's also Rigidbody2D. Oh, I already have one. So Rigidbody2D. So let me reset it. So it's usually like this. Let me open this up a bit. So body type dynamic is when it's using force and gravity at all times. So if let's say I have it at dynamic and I hit play right now, as you can see it falls down. Now my block did too, because it probably has the same settings. See, dynamic. So let me just turn this off real quick. Now for the bomb, there's kinematic. Now kinematic, if I hit play, kinematic, as I said before, it doesn't move unless you tell it to through script. So as you can see, it's not moving, but it's still I'm pretty sure it still collides with other things. Let's test this out real quick. So yeah, it still allows you to collide. Now static is used if it's not going to move at all. So then a dynamic, if it's going to move, if it needs to move by itself without you actually controlling the movement. Kinematic, if you're going to be controlling the movement, you know, with like input. Static, if there's not going to be any movement, but you want it to actually still, you know, be able to collide. Now if it's static, it's going to act like it's super heavy and you won't be able to move it at all. So no matter what I do, if I add say I add some mass to my player, like 100, it still won't do anything. So no matter what, it will just stay put, because it will be considered a static rigid body and a static game object. Now static, as you can see, it's up here. Static just means it's not gonna move. Now there's, let me go back to dynamic. There's physics material 2D. As you can see, they all have it. Now I covered the physics material 2D in a previous video. I'll leave you a link up above. It just lets you add bounciness or other things to it. Now there's simulated. So if you want this to actually simulate, so like, let me hit play real quick. So as you can see, it actually works. It actually falls down. And let me hit simulated. Let me keep it off. So now it don't do nothing because there's no simulation. It's not working with the physics engine. Now use auto mass if you want it to automatically, you know, get the mass of the object. So right now the object is at 0.27, because that's what what Unity calculated. Now you don't have to have that set. Linear drag is just like an air resistance to your objects. So like if that air was going against your objects and, you know, making it slower. Same thing with angular drag, but that's when your object is rotating. So when it's rotating like this, it'll just slow it down. There's also gravity scale. So this is the scale you want the gravity to be. So if you add a higher, or if you have a higher scale, it will fall more rapidly. So as you can see, it fell really quickly. You could even notice. Let's see. Let me put it way up here. See, it falls real quickly. Now it went through because the collision detection is discrete. When it's a fast object like that, you want to have it to continuous. That way it continually detects collision. So let me go up and just kind of test it out for you. So now when I hit play, it collides because it's running the collision. It runs it more often than usual. Now I forgot to tell you about gravity scale. You could also put it in the negative side. So let's say, well, actually let's keep going. Before I show you the negative side, let me show you what it happens when you have a low gravity scale. So when you have a low gravity scale, what happens is pretty much it just falls slower. So as you can see, it falls much slower. Now if you put it on the negative side, what happens, it just goes, instead of going downwards like gravity works, it goes upwards. So as you can see, it's moving upwards instead. So after that, there's sleeping mode. Never sleep. I read in the documentations that it should never be used, or at least rarely be used, because it could let me check it real quick just so we're on the same page. So it says never sleep. Sleeping is disabled. This should be avoided when possible, as it can impact system resources. So if you could avoid it, it's best to avoid it. Now there's start awake. So as it implies, it starts awake. Start asleep, it will start asleep and it will pretty much react when there's a collision. So if you have something that's pretty slow and they're gonna collide kind of slowly, just push start asleep. That way when they collide, this component will will work. So it's pretty much like this component gets disabled. When it collides with something, it gets enabled. It detects the collision, and then it does what it has to do. Now interpolate. Let me get the exact. Says the movement is smooth based on the previous frame, and then extrapolate, it is smooth based on the next frame. So this one's based on the previous frame that it gets smooth, and this one is based on the next frame. Constraints, so if you want to freeze a position, so if you don't want it to move on the X, or if you don't want it, so the X would be, you know, left and right. You don't want it to move it on the Y, up and down. And then Z, if you don't want it to rotate at all, so if you don't want it to be spinning on the Z axis. And then there's info as well. Info just gives you some information of where it's at. As you can see, the position, it gets updated. So I'm gonna move this. Rotation, if I actually rotate it, you can see the rotation here. The velocity, so if there's an actual velocity at the moment, this is usually on runtime. So let me see if I can show you. Just look at over here, see if we can see the velocity. So we can see the little velocity for a second. Let me show you again. Maybe my mouse was in the way. As you can see on the Y, you can see the velocity, and you can see some numbers adjusting below that as well. The world center of mass was adjusting and all that. As you can see, the sleep state is asleep right now. It's awake because it's not touching anything. So it falls asleep after a couple seconds of actually colliding with something. So as you can see, you could have it as start asleep, and it's asleep, and it wakes up, falls asleep. Yeah, as you can see, there's a little debugging tools for you. And then there's contacts. It shows what contacts you have. So as you can see, there's this point of contacts. There's the actual collider it contacted with. If it has a rigid body, it would show which rigid body, and then it shows the other collider, which is the same collider that's on this game object. So as you can see, those are just little debugging tools so you can see. And let me check how much time we have left. So I'm gonna wrap it up for today. Or actually, before I wrap it up, sorry about that, I'm gonna continue on to kinematic real quick. Kinematic is pretty much the same thing. It has this physics material simulated. So if you want it to be running or not, use full kinematic. So if you want any kind of collision to be affected by this, so if you want static collisions to affect it, if you want dynamic and kinematic collisions to detect this, you know, you would check this. Collision detection, the same as the other one. If it's gonna be super rapid, just continuous. If not, just click discrete. Sleeping mode, same thing. Never asleep, you shouldn't really use it. Start asleep, it'll start asleep and it'll wake up when it has some movement, some contact. Interpolate is it smoothens out movement before a frame. Extrapolate smooths it after the frame. And then of course the same thing, the freeze positions, same thing here. Got info, contact positions, and as you can see, it don't work unless it's actually running, at least the contact position. And then there's static. It just has this debugging tools as well. And then simulated, so if you wanted to simulate or not. And a material. So if you add a material to this, let's say a bouncing material to this, so this isn't gonna move, but whatever actually hits this and has a collider will bounce off of it. So yeah, that's pretty much it for this tutorial. I hope this helped you guys out. If you guys have any questions, let me know. I just want to thank all the subscribers have subscribed and watched and follow this channel. I really appreciate it. Almost to 50. I'm kinda glad about that. I really do appreciate it. And anyone that wants to help me out, help this channel out, you know, hit that like button, hit that subscribe button, leave comments of anything you want to see in the future. If you need any help, let me know. Thank you.